Welcome to the lesson on the overview of EV batteries. In this lesson, we will explore battery technologies and the different types of batteries used in EVs. By the end of this lesson, you will be able to describe a battery and learn about its fundamental components. You will also be able to describe an EV battery along with its components. After that, you will be able to differentiate between an EV battery and an EV battery pack. Next, you will familiarize yourself with the various batteries used in EVs, and finally, you will be able to describe the different types of EV batteries. In this lesson, we will provide you with an overview of a conventional battery and an EV battery, the distinct features of an EV battery, and the main difference between an EV battery and an EV battery pack. We will also cover the overview of EV battery types, focusing on some main batteries: lead-acid, nickel metal hydride, lithium-ion, and solid-state. Batteries supply electrical power to a variety of devices, such as flashlights, radios, cell phones, handheld games, and many others. A battery serves as a container that stores energy until it is required. Within the battery, there are chemicals that store this energy. When the battery is in use, the chemical energy undergoes a transformation into electrical energy. Inside a battery, you will find two metallic components immersed in a liquid or paste. These metallic parts are referred to as electrodes. The liquid or paste, known as an electrolyte, is a mixture of chemicals. Each electrode features a terminal, a point that protrudes from the battery. To make a battery function, these terminals must be connected. Subsequently, the chemicals within the electrolyte initiate the flow of electrons from one electrode to the other. This flow of electrons creates an electric current. EV batteries, specifically lithium-ion batteries, comprise several smaller units called cells. Each cell contains three essential components: a positive electrode, a negative electrode, and an electrolyte. The positive electrode is typically composed of lithium metal oxide, while the negative electrode is usually made from carbon, such as graphite. During the charging process, the lithium ions move from the positive to the negative electrode through the electrolyte. This is an oxidation reaction, meaning the lithium ions lose electrons. The electrons flow through the external circuit to the positive electrode, which charges the battery. During the discharge process, the lithium ions move from the negative to the positive electrode through the electrolyte. This is a reduction reaction, meaning the lithium ions gain electrons. The electrons flow through the external circuit to the negative electrode, powering the drive motor. The positive and negative electrodes are separated by a separator, which is a thin, porous material that allows the lithium ions to pass through but not the electrons. The separator prevents the electrodes from short-circuiting. The key here is that the flow of electrons is essentially electricity. So, when an EV is being driven, it uses the stored chemical energy in the battery and converts it into electrical energy. This electrical energy gets converted to mechanical energy by the electric motor to move the car. The EV battery stores chemical energy that can be converted to electricity when needed. When the driver steps on the accelerator, the battery releases large amounts of electrical current, providing the necessary power for quick starting and acceleration. This instant burst of electricity from the battery and the other components propel the vehicle forward. The EV's battery not only stores energy but also recharges quickly during decelerating or braking moments. This regenerative braking system, which is a technology that allows an EV to convert the kinetic energy generated during braking into electrical energy, which is then stored in the battery for later use, harnesses the vehicle's kinetic energy, converting it back into electrical energy to recharge the battery. As a result, the battery gets replenished, ensuring it is ready for the next acceleration. The size and capacity of an EV's battery are the two main factors determining its range. The size of the battery refers to its physical dimensions, while capacity refers to the amount of energy that it can store. Let us now look at the main difference between an EV battery and an EV battery pack. An EV battery is a group of individual cells that store electrical energy. In contrast, the EV battery pack is the complete assembly of multiple EV battery cells organized together with additional components, such as a battery management system, BMS, that help to control and protect the battery cells to form a functional and integrated unit for powering the EV. The choice of battery type in an EV is a critical factor that greatly influences factors like range, charging speed, durability post-warranty, and overall safety. Now, let us take a look at some of the main types of batteries used in EVs. They are lead acid, nickel metal hydride, lithium ion, and solid-state batteries. Lead acid batteries are typically used to power the vehicle's electrical systems and start the main high-voltage battery pack. Nickel metal hydride batteries are commonly used in hybrid vehicles for propulsion. They will likely continue to be used in the future, but they are also gradually being replaced by lithium-ion batteries. Lithium-ion batteries are the most common choice for BEVs and will likely remain the dominant type of rechargeable battery. Solid-state batteries are in the research and development stage. However, there is a lot of promise for this technology, and it is possible that solid-state batteries could become commercially available as an alternative battery type in the near future. The type of battery used in an EV will depend on several factors, including the vehicle's design, performance goals, and budget. Lead-acid batteries are important in powering 12-volt systems, including the essential computer controls in EVs. They contain metallic lead, a negative electrode, lead dioxide, a positive electrode, and sulfuric acid as the electrolyte. In the past, lead-acid batteries were the first type of rechargeable battery to be invented, and they are still the most common type of battery used in the world today. They are used in a wide variety of applications, including cars, trucks, boats, and laptops. Though lead-acid batteries are still globally used at present, they are gradually being replaced by other types of batteries, such as lithium-ion batteries. This is because lithium-ion batteries offer a higher energy density and a longer lifespan than lead-acid batteries. These batteries hold several advantages. They are cost-effective, readily available, reliable even in challenging conditions, long-lasting with proper maintenance, and environmentally friendly due to their recyclability. However, lead-acid batteries do possess certain disadvantages. They are relatively heavy and present safety concerns due to their lead content and the presence of hazardous sulfuric acid. Additionally, hydrogen gas emission during charging necessitates adequate ventilation to mitigate fire and explosion risks. Nickel metal hydride batteries are widely used in hybrid electric vehicles. The components of these batteries include hydrogen-absorbing alloys, nickel hydroxide, and potassium hydroxide. Nickel metal hydride batteries were developed in the 1960s, and they quickly became the most popular type of rechargeable battery for portable electronics, computers, and medical equipment. They offered a significant improvement over nickel-cadmium batteries, with a longer lifespan and a lower self-discharge rate. These batteries are still widely used in portable electronics, such as cameras, laptops, and power tools. They will likely continue to be used in the future, but they are gradually being replaced by lithium-ion batteries. Lithium-ion batteries offer a higher energy density and a longer lifespan than nickel metal hydride batteries. Nickel metal hydride batteries have several advantages. They have a high energy density, which means that they can store a lot of energy in a small package. They have a long lifespan, which means that they can last for many years with proper care. This can save EV owners money in the long run. They do not suffer from the memory effect, which means that they can be recharged at any time without affecting their performance. They are recyclable, which helps to reduce the environmental impact. Nickel metal hydride batteries also have disadvantages. They are more expensive than other types of batteries, such as lead-acid batteries. They have a high self-discharge rate, meaning they lose power over time, even when unused. This can reduce the amount of time that an HEV can run on a single charge. Their cold weather performance is not as robust as other battery types, such as lithium-ion batteries. Lithium-ion batteries are the most common type of batteries in BEVs and plug-in hybrid electric vehicles. A lithium-ion battery powers the high-voltage systems such as the drive motors, inverters, and compressors of an EV. The major components in lithium-ion batteries are lithium, manganese, cobalt, graphite, steel, and nickel. These batteries were first developed in the 1970s, but were not commercially available until the 1990s. They quickly became the most popular type of rechargeable battery for portable electronics, such as laptops and cell phones. These batteries are now the most common type of rechargeable batteries globally. These batteries are likely to remain the dominant type of rechargeable battery in the future. They are constantly being improved and becoming more affordable and efficient. These batteries have several advantages. Like nickel metal hydride batteries, lithium-ion batteries have a high energy density, meaning they can store a lot of energy in a small package. This is important for EVs, which need to be able to travel long distances on a single charge. They can be charged quickly, which is important for EVs that need to be recharged frequently. They have a long lifespan, meaning that they can last for many years with proper care. They do not suffer from the memory effect, meaning that they can be recharged at any time without affecting their performance. They are recyclable, which helps to reduce environmental impact. These batteries have a few disadvantages. They are more expensive than other types of batteries, such as lead-acid batteries. They are sensitive to heat, which can cause them to malfunction or even catch fire. Solid-state batteries are an emerging technology that is still in the development and testing phase, and their commercialization for EVs is anticipated in the coming years. While they are not as mature or widely used as the battery types previously discussed, they hold great promise for the future of EVs. Solid-state batteries use solid electrolytes instead of liquid or gel electrolytes found in conventional lithium-ion batteries. They offer several potential advantages, including higher energy density, improved safety, faster charging, and longer lifespan. Let us recap what we have covered in this lesson on the overview of EV batteries. A battery is a device that stores energy until it is needed. Chemicals inside the battery store the energy. When the battery is used, the chemical energy changes into electric energy. An EV battery pack is the complete assembly of multiple EV battery cells organized together with additional components, such as a battery management system, that help to control and protect the battery cells to form a functional and integrated unit for powering the EV. Lead-acid batteries were widely used in earlier EVs, but they had their drawbacks since they were heavy, had low energy density, and had a limited range. Nickel metal hydride batteries provide improved energy density, longer range, and reduced weight. Lithium-ion batteries revolutionized the EV industry with higher energy density, lighter weight, longer lifespan, improved safety, and declining costs. Solid-state batteries, an emerging technology, have the potential to offer higher energy density, improved safety, faster charging, and longer lifespan, and could play a crucial role in the future of EVs. By understanding the different battery types, you will gain an understanding of batteries and their role in EVs. Thank you.